dealing with scale, reliability, governance, and real business outcomes. He's a Silicon Valley-based executive with wide-ranging deep tech and AI expertise from augmented and virtual reality, autonomous driving, large language models, computer vision, and cybersecurity. Please put your hands together, ladies and gentlemen, and welcome on the stage, Mr. Sanjay Krishnan.
Thank you. Okay. And can I move back? Hello, hello. Good morning, everybody, and thank you for coming. Thank you for the L&T folks for organizing this. Today, we're going to dig into enterprise agents, enterprise AI agents, what works in real life and what doesn't. And I'm going to keep this talk in two parts. First, we're going to go into what an enterprise agent is and how it's architected, right? And so just to get an overview and see all the various types of enterprise agents that are out there. But we're also going to do a very interesting case study in lending, and I think that'll be super relevant for all of you, and I think you'll really enjoy this. So I've put this together, and I have tried to be broad, as well as in a few places pretty deep, and go into what actually works, what doesn't work. So I'm hoping that all of you will be able to get something out of it. Let's jump right in. A little bit about me. I know the introduction already told you a lot about who I am and what I do, but I've been a tech and product guy since the early days of AI when I used to work at Google more than 10 years ago now, and I've launched since then and scaled at a couple of different startups, AI products. I've mentored startups at myself at Silicon Valley in Berkeley and Stanford. And a few other places. I've taught a course on enterprise AI agents at Stanford University, and I myself an IIT Madras alumnus from many years ago. So that's a little bit about me. Okay. Just to set the stage here, just to make sure that we all understand what is an agent, right? Make sure that we understand the difference between an assistant and an agent. By now, if you've used any AI, you probably know this already, but just bear with me here. An agent answers questions, but an assistant answers questions, but an agent can actually complete a task for you, right? It's trained on, an assistant is usually trained on data, not so much on the workflows. And that's really the key here. And we'll look into some enterprise workflows and what works and what doesn't and how difficult it can be to replace an enterprise workflow, which is what really an agent is trying to do. And by the way, one common thing between the two, whether you're talking about assistants or agents, they can all make mistakes, okay? And so that's where you see the fine print. No matter what type of agent you're using, this can make mistakes, okay? And there's no such thing as reliable because humans make mistakes too. Okay. Enterprises have so many different functions, right? And there are AI agents, and there are startups developing AI agents for each of these functions. How do we look at what actually works, or which ones are more mature versus which ones are still in early stages? This graph out here actually tells you, ranks by size of average startup in that space, tells you which ones are actually a little bit further along in terms of the functions that the enterprise agents are working on. Legal, you can see legal, sales and marketing, recruiting are up there near the top, okay? And the reason for this is pretty obvious. These are workflows that are highly language-based, right? Looking at documents, summarizing documents, providing insights from it in one way or the other is a lot of that workflows. Now, if you're working in finance and you see yourself down in almost at the bottom of this list, there's a reason for that. And there's a reason for that is because there's a lot of workflows that involve various types of judgment based on numbers. These are not simple. Sometimes you have to figure out what types of analysis to do in order to get the right numbers and then make the insights. But don't worry, agents are coming. Okay, that's my message to you. There are lots of good agents that you already saw today earlier what L&T Finance is doing, but there's lots of other ideas, including in lending use cases, that I think we will, and I will show you some of that today later in my deep dive, that agents will be able to help you, as in you, a finance professional working for the finance industry, to actually help your workflow as well. All right, but first, okay, what do these agents actually do to deliver business value? I want to say if there's one thing you take away from this presentation, it's that business value requires full task delegation, okay? And full task delegation, by the way, requires full context. Seems fairly simple, but I just want, this is worth remembering because a lot of times we forget that when we are using AI agents that maybe this will do, 80% of my job. Well, that's actually not enough because the business value really depends on being able to tell an agent, this is the outcome I want, and the agent should then be able to take it from there and go make it happen, right? And that's what really I mean by full task delegation. It doesn't do half a task, just like if you were to delegate to a human, half a task is not really that valuable, right? And by the way, if you want a full task delegation, you also want to make sure that the agent has the full context of what it's doing, why it's doing, what's the data it needs to do, and what it needs to remember from previous transactions. And so that's what I really mean by full context. And by the way, this is, what I just showed you is a rephrase of what actually came in the Anthropic Economic Index report just a couple of months ago, where they actually came to the same conclusions, right? That the majority of business use cases involve automation usage patterns that need full task delegation, and that the biggest bottleneck that we're going to face very soon is the bottleneck of trying to give that full context to an AI to actually accomplish that task so that you can delegate to the AI effectively. Okay, so what does all this mean in terms of the architecture of agents? I've put it together in one sort of big picture, but in the center of this picture is what I call the context engineering, right? There's an underlying language model, but there's a lot of planning and execution that your agent has to do, and that's what we are in this, what we call the agentic flow or workflow in the center. But there's two important things on the side. I want you to keep that in mind also. One is the human oversight, which we all know. This is called usually implemented in the form of either reinforcement learning or some sort of evaluation with human feedback. And on the other side is data governance. This is an important piece which is often overlooked, and I have to mention it here because any enterprise agent needs to work on data, and it's usually there are regulations or compliance requirements or some other constraints on what data is actually needed by what agent at what time, and these have to be respected by your agentic AI framework. So this is the emerging model, which is in the center. We have what we call the agentic workflow, but on either side you have these guardrails with the human evaluations on one side and the data guardrails on the other, right? So we'll go through some of these examples in a little bit deeper in the case study that I'm just going to give you in business lending. A lot of these insights are coming from my friends at Agami AI, and I'll tell you more about them later. All right, jumping right in. Let's look at a business lending use case, okay? I divided this into 4 sections of what a loan officer or a loan team is going to go through. And imagine you are in the enterprise. For some of you who are working in this, this may be very familiar to already. But imagine you're a business loan. You're making small and medium enterprise or even big enterprise business loans. You're a loan officer, or you're one of the other folks in the bottom here of this flowchart of what your job description is. Okay, you may be a credit analyst, loan officer, credit team, underwriting team, or the committee that is actually in charge of making the final decision and recommendation. There's lots of stuff this entire team has to go through, right? Starting from understanding documents which are submitted, and usually these are bank statements, financial statements, digest it, find out what the actual ratios of interest are in terms of, let's say, the debt service ratio or your actual assets and liabilities ratio or various other financial ratios that matter to you in this context. The financial analysis, which compares year-over-year growth in these things, in these ratios of interest, and finally feed all that into certain rubrics or guidelines that your enterprise has in terms of making these decisions, and then you or your team has to come up with the final decision and final recommendation, right? There's a lot of complex things going on in here. Each of these bullet points in this slide is actually an agent that is replacing or doing the particular task that the human would do. Okay, so this, if you think of this entire thing as a lending agent, it's actually not one big agent. It's composed of 10 small agents doing each of these small tasks, augmenting the human who would do each of these tasks individually, right? From data, from the document understanding all the way to the final recommendation. And this is coordinated in a system of agents manner from one agent to the next, step by step. And we'll go through some of those examples as we go through this, okay? And I'm going to dig deep into the final agent here, which is the recommendation agent, because I think that is a little more interesting to give as an example. Plus, also in the time we have, I cannot go through every single agent in much detail. Looking at the first 3 steps, okay, I want to point out some of the bank statements and just document understanding and financial analysis is a huge task if you don't have normalized data. Now, normally we've relied on, OCR and things like that in the past, but what's happening in today's like vision language models and understanding of data, you can feed it, your bank statement in the form of a PDF. Here's an example from, a bank statement that you get from a bank, right? Canara Bank in this case. But what you really want is you are interested in certain normalized representation of it. You want the account number, name, balance. You also want the transactions in a particular way and order, and so that you can then ingest it quickly into your algorithms, right? And so to be able to do that, step 1 is just what I call document understanding. And imagine if you have dozens of different banks, each one with their own format. Normalizing this is a huge first step. And this agent that I just showed you in the previous slide, the first agent, which is the document understanding agent, right, is able to take this input on the left-hand side and produce that on the right-hand side. Now, PDFs look simple, but if you go to a financial data, for example, there are chartered accountants who will, literally type up. I used to have a chartered accountant. In 2020, he used a typewriter. Okay, so this kind of data, which is then scanned, photographed, and sent to you as part of a loan application, guess what? This AI, right, has been trained, and there's a lot of synthetic data that goes into this training, and I can tell you more about that if you want. Find me after the talk. I'll explain that in more detail. But this is able to take that, what you see on the left-hand side, and produce a highly standardized form which includes the items of interest that you really want, like gross receipts, annual operating margin, operating income, interest received, and so on. I'm only showing you a small snapshot on the right-hand side of the full data that's actually useful and needed for doing the analysis. But you can see from here how useful it is to be able to throw in any sort of non-standard document in any non-standard format. Forget the bank statement, which was a PDF. This is even more difficult, right? But this is what state-of-the-art is in terms of AI and these vision language models. They're able to understand these in very quick way and with very high accuracy. And I'll tell you a little bit more about the accuracy that we're able to achieve to actually get to what we're seeing on the right-hand side. Okay, now I'm going to jump forward to this recommender agent, right? I just mentioned to you in passing in the first slide these 4 steps. Step 4 is this recommending agent, which takes all this data that you have, the first set of agents has produced, and now it's going to come up with a recommendation output. It's going to come up with two sets of outputs. The first is a decision summary, which is approve or reject, or a conditional approval. There are 3 types of outputs possible. And it's also going to come out with what's called a credit memo, right? Which is a narrative of what you actually, why you made that decision, right? But to get to that, you need to go through several steps, which is what I referred to earlier as the context engineering here, okay? So the context engineering includes, so if you look at on the left-hand side, you have configuration, RAG, which is retrieval augmented generation of the information database, contextual memory, and databases, right? All of these are used in respectively giving you examples, the policy documents, financial insights, and actually the borrower application details, right? And so each of these sort of inputs that are coming in are all context to the agent. And each of these contexts is fed in a different way to the agent that has to make the final recommendation decision. And there are different techniques, and each of those techniques is now well established in the field of context engineering on how you provide the right context to the right agent at the right time so that it can then make the right decisions for you. Okay, underlying all this is, of course, language models. I didn't really talk about the language model itself here. It turns out that the choice of language model itself is not that important. More important is how you construct the entire workflow, the agentic architecture. And this works reasonably well with no matter what type of language model you use. In this case, we've used Llama or GPT open source and actually works out pretty well. Let me walk you through a little bit more detail in a few minutes on what exactly the prompts look like, okay? If you read this carefully, this is what we've been doing with prompt engineering, right? You are a recommender agent for a business, whatever, credit private limited. Your role is to prepare a credit memo decision based on the borrower's application, financial metrics, etc. Be factual, be policy aware, use Indian credit terminology, CIBIL score, DSCR, etc., right? So it gives you all that context and also says you must produce one output, which is a decision block. So this is the level of detail into which the context has been given in terms of the prompts for these things. This is, by the way, I'm only showing you the example of this recommender agent. There are other agents, and each one of them has their prompts and has their context provided to it in appropriate ways. There is a task block. There is an output format block where it actually says, we want the decision to be one of these three things, and we want summary points, we want risk factors and conditions, and finally you'll notice something called confidence, and I'll tell you what that is. I don't know if you can read this, but I'm continuing what the context is being given to this recommender agent. How to arrive at the decision, right? Compare the key ratios. If the DSCR is less than 90% of the policy minimum or leverage more than 120% of the limit, then you reject, okay? Then there is also when do you approve? And then in the middle, if it comes to a conditional approval, then we continue saying what are the conditions that you would want to see in order to make this a conditional approval. And finally, this confidence score, right, is something that is to give you an idea of how confident the agent is in coming with a conclusion. We've given the guidelines to calculate a confidence score also, right? So for example, if some key ratios are missing, or if there are conflicting insights or the multiple data or inconsistencies, that reduces your confidence. It doesn't mean the decision changes, it just means the confidence in the decision drops. Okay, this then can be looked at by the final human person who is actually reviewing the agent's recommendation to decide whether the agent made the right call, or if this is too low a confidence, then should we go back to the borrower, ask for better data, different data, and things like that, okay? I'm going to show you an example of what the recommender output looks like. Okay, this is an example from an application. This example is showing a conditional approval. So the person has been approved with a condition. Look at the summary text. It actually tells you, gives you the insights from this application, like the revenue is up 12% year over year, DSCR is slightly below the policy norm, current ratio exceeds blah, blah. And by the way, it also tells you promoters have strong rural distribution network and maintain clean repayment history. So it's actually got all of that information from the analysis of the documents that it's done before, right? It's listing out the risk factors, and then it's giving you the conditions, and it's giving you a 90% confidence score. So fairly high confidence that the conclusion that is come to is good based on the data that has been given, right? So this is an example of how we're able to go from the beginning to a final output, right? And if you are a loan officer, you feed in all the documents and you get this at the output, that really is a game changer in terms of like the amount of work that's been saved and the time that's been saved to make this actually happen. Okay, quickly we'll look at evals. I'm not going to go too deep into this, but evaluation, known as evals, right, is basically how do you evaluate this whole agent, and how do you provide that human feedback so that this agent improves over time. This particular example was started out as something like 60% accuracy, but went over time to get more than 95% accuracy, right? And the way to do it is by giving it examples and then giving it feedback whether it made the right decision or not. And the way you do these evals is by actually using an evaluation, giving it evaluation data, an evaluation harness, and there are tools to do all of these, by the way, and giving it human feedback in terms of whether it got it right or wrong. I'm going to skip over this actual deep eval framework that was used to come out with this thing. Anyway, let me tell you the final result of what kind of performance was actually achieved. So this, using the Llama 3.1 8 billion model, which is an open source model from Meta, right, which actually allows it to run on an L4 NVIDIA GPU with 48 gigabytes of VRAM, produce this entire latency, okay, from the data ingestion all the way to recommendation output of 75 seconds. All right, so just over a minute to process this whole thing and give you an output. Accuracy was more than 99% for the common format documents, right, like tax returns and GST receipts, which are like highly structured, but more than 95% even for the very unstructured documents that we found, like, for example, financial statements, literally taking a photo and sending it. And it's able to get more than 95% accuracy in getting the insights out of those that actually matter, which is huge, I think. Now, it's not 100%. Okay, there's always going to be some mistakes, and that's why you need humans to oversee this whole thing. But even at that point, I think it's a huge improvement over, or a huge help in augmenting what the human does and making, 95 times out of 100 makes the right decision, makes the correct decision, gets the data correctly. It's actually really, really useful, right? And extremely fast, of course. What would take, probably hours of human time has brought it down significantly. And the cost, if you run this using these GPUs that I mentioned at roughly 10,000 loan applications a month, it actually comes to roughly 33 cents per loan application to process through this entire pipeline. And that includes the GPU cost, but also the server and database cost. So all in, the cost is significantly low, the latency is significantly low, right? Very short. Accuracy is significantly high. So if you are a CFO in this audience, or somebody who's actually managing huge teams, you're going to save probably more than $100,000 a year in terms of like your team's efficiency going up. And if you're a CTO in the audience, or leading an engineering team, make sure you understand all of this. Pivot your engineering team to point them towards context engineering, towards building an agentic AI using commonly available frameworks that you can actually build something that actually solves real business use cases, solves it with high quality, repeatability, robustness, production scale, and very low cost. And the business teams are going to love it because this is what they've been waiting for. And I've given you an example here of the lending agent. But the same thing is across the enterprise, right? From legal, sales, marketing, HR, accounting, supply chain, finance. All of these enterprise functions have the same opportunity to get a huge step up in their improvement in productivity at very low cost using these agentic frameworks. All right, thank you. That's really all I had.
Well, thank you, Sanjay, for sharing those practical and real-world insights. Thank you so much. Now I request, ladies and gentlemen, the financial controller for L&T Finance to please come on the stage, Mr. Keshav Loyalka, to present the token of appreciation to Mr. Sanjay Krishnan. We can have a round of applause.
Thank you. Thank you. Thank you.
Thank you so much.